On behalf of Advantage India, I welcome you all for this wonderful workshop on natural gas engineering, operation and supply chain and marketing. The agenda of the workshop are midstream and downstream processing, natural gas marketing, gas procurement and trading, gas regulatory framework, security and marketing practices, distribution of gas. Um, just a little note for you. If you have any question during the presentation, please type them into the question box. After the presentation, we will also have time for the question at the end. Now, without further ado, we'll turn the time over to presenter. Our presenter is Yogashri Pradhan ma'am, who has completed her bachelor's in petroleum engineering from Texas Board of Professional Engineering, her master's in petroleum engineering from Texas A&M University. Now she's currently working as senior reservoir engineer in Endeavor Energy Resources. She is also volunteering for SPE as SPE Cares co-founder and many more to add. Now I would like to hand over this to Yogeshri ma'am and she could start the present now. Thank you so much, ma'am.
Thank you, Rishari. As Rishari mentioned, I'm Yogashri Pradhan, and I'll be giving a Friday course on the introduction to natural gas and all the agenda topics that Rishari already mentioned. Go ahead and finish my slide. Okay. A little bit about myself. I'm from Midland. I'm a senior reservoir engineer for Endeavor. I worked for Endeavor for about 3 years now. And prior to that, I worked as a production engineer for Texas Oil and Gas Institute. And before that, I worked as a production engineer for Devon Energy in Midland, Texas as well. And I've already mentioned my education, but some hobbies about myself. I like to read, I hike, and I volunteer for SPE. So for those of you who want to volunteer for SPE, I strongly suggest you do so. Where exactly is Midland and where am I located? So this is Midland, Texas, and this is located right over here in the United States compared to India. So this is a town in West Texas where it's been the center of the Permian Basin. So this should give you an idea of where exactly I'm from. So this is the agenda topics for the presentation, what you should expect from me. For the expectations would be how gas gets to the market, how it's sold, and how it's used by end consumers. Midstream and downstream industries. Midstream and downstream industries are structured. Typical gas end users or sectors. Power generation, industrial sector, commercial and residential sector, and their peculiarities. How international gas markets work. How legal and regulatory frameworks are typically designed and implemented, and then other issues if we have the time. What I expect from you is, as Rishari already mentioned, make sure you ask a lot of questions. I encourage a discussion. Please share your experiences and learnings. And did I mention ask questions? And then when you ask questions, make sure you introduce yourself. Here's the course outline, which I've already mentioned. We'll first talk about, for today, we'll talk about the natural gas marketing. So what exactly is gas marketing? It's simply put the selling of natural gas, and it's the processing of coordinating at various levels the business of bringing natural gas from the wellhead to end users. And it's pretty complex. It doesn't necessarily fit into one spot in the natural gas supply chain, and I'll show you that later on. And these marketers may be affiliates of producers, pipelines, local utilities, and separate business entities unaffiliated with any other players in the natural gas industry. So marketers define buyers for natural gas, they ensure secure supplies of natural gas in the market, and they provide a pathway for natural gas to reach the end user. They ensure a liquid, transparent market exists for natural gas, and they're primarily concerned with selling natural gas either to resellers or end users. On average, most natural gas can have up to 3 to 4 separate owners, and their expertise in financial instruments and markets both reduce their exposure to risk to inherent commodities, and they earn money through speculating as to future market movements. And they include all the intermediate steps that a particular purchase requires. So that includes arranging transportation, storage, accounting, and any other step required to facilitate the sale of natural gas. They also serve to facilitate the movement of natural gas from producer to end user. They're the middlemen between two parties and can offer bundled or unbundled service to the customers. They may be present at any two parties to facilitate the sale or the purchase of natural gas. They can also contract for transportation and storage. They may own natural gas being transferred, or they facilitate the transportation and storage. And there are a myriad of different ownership pathways that exist for natural gas to proceed from producer to end user. So this is what I meant, how marketers could be at any part of the natural gas supply chain, where you have marketers in between the producer and the interstate pipeline. You have marketers in between the interstate pipeline and the local distribution company, or LDC. And then you have marketers in between the local distribution company and the end user. So there's a regulation of wellhead prices, as well as assured monopolies of large transportation pipelines and distribution companies that led to little competition in the marketplace. Then there were incentives to improve the service and innovation were few. And the regulation of the industry also led to natural gas shortages in the 1970s and surpluses in the 1980s. So the industry today has changed dramatically, and it's much more open to competition and choice. Wellhead prices are no longer regulated, meaning the price of natural gas is dependent on supply and demand interactions. Pipelines no longer take ownership of the gas commodity. They only offer the transportation component. And LDCs continue to offer bundled products to their consumers, although retail unbundling taking place in many states allows the use of their distribution network for the transportation component alone. End users may purchase natural gas directly from producers or local distribution companies. So exploration and production include finding and developing gas. So the question I wanted to ask is, who are natural gas producers? So exploration and production companies, they drill wells and they produce gas from natural gas fields or gas that is produced in association with crude oil. This is a chart from the EIA and shows you some of the top producing natural gas countries in the world. And you have the United States growing in their natural gas production. You have Russia being stagnant or being pretty consistent in the natural gas production. And then you have Saudi Arabia that is emerging, but it's pretty consistent in their natural gas production, but they have a surplus in oil production. U.S. dry natural gas production increased by 12% in 2018 to 28.5 billion cubic feet per day, and that's reaching a new record high. So there's ongoing growth in liquefied natural gas export capacity, and the expanded ability to reach new markets have supported increases in U.S. natural gas production. Russia's natural gas production increased by 7% in 2018, which exceeded the growth in exports. The Yamal liquefied natural gas, or LNG export facility, loaded its first cargo in December 2017. It could liquefy more than 16 million tons of natural gas annually and accounts for almost all the recent growth in Russia's LNG exports. And then since 2000, more than 80% of Russia's natural gas exports have been sent to Europe. I wrote down the top natural gas companies, and you've probably recognized some of these names, but you have Gazprom first, and then you have Eni as the 10th one. So these are the top 10 natural gas companies that produced about 30% of the world's natural gas in 2016. The US is the top producing country of natural gas in the world, and Russia's Gazprom is the world's top publicly listed natural gas company. I'll talk a little bit about processing and transportation. So with processing, you're removing impurities and separates higher value products that are sold in separate markets. It prepares a dry gas stream that meets the industry standards for transportation and high pressure pipelines. Pipeline companies require that natural gas provided at the inlet of their pipelines conforms to certain quality specs in order for it to be transported on their systems. Only natural gas meets these specifications is transported on the extensive North American pipeline grid. Natural gas is transported in high-pressure pipelines from producing areas to local distribution companies, storage areas, industrial end users, and electricity generation facilities. So I mentioned a little bit about LDCs, or local distribution companies, but what exactly are they? They own and operate a network of pipes that carry natural gas from high-pressure trunk lines to final consumers. These consumers include residential, commercial, electric generation, industrial consumers, although large electric generators and industrial consumers frequently take service directly from pipeline rather than from a local distribution company. LDCs are regulated utilities involved in the delivery of natural gas to consumers within a specific geographic area. And then there are two basic types of natural gas utilities, those owned by investors and public gas systems owned by local governments. They typically transport natural gas from delivery points located on interstate and intrastate pipelines to households and businesses. The delivery point of this natural gas is transferred from a transmission pipeline to the local gas utility, and it's often termed as a city gate, and it's an important market center for the pricing of natural gas in large urban areas. Utilities take the ownership of natural gas at the city gate, and they deliver to each individual's customer meter. It requires an extensive network of small diameter distribution pipe, and the U.S. Department of Transportation's Pipeline and Hazardous Safety Administration reports that there's over 2 million miles of distribution pipeline in the U.S., including city mains and service pipelines that connect each meter to the main. So this is just giving you a view of what the local distribution companies and how the pipeline transmission looks like. And you'll notice that it's small diameter pipelines, you're transmitting the whole bunch of gas. So there are safety measures for local distribution companies, such as leak detection equipment, safety education programs, technicians on call, emergency preparedness, and one-call systems. I'll talk a little about leak detection equipment. They have utilities in place using sophisticated leak detection equipment, and it's designed to pick up on leaks of natural gas from the distribution network. Utilities also adds odorants to the natural gas to make it easier to detect a leak. For safety education programs, they run natural gas safety seminars in schools, community centers, and through other organizations to ensure customers are well versed in the natural gas safety procedures and they know what to do in the event of a leak or emergency. For technicians on call, utilities maintain fleets of technicians on call 24 hours a day, 7 days a week to respond to customers' problems and concerns. There's emergency preparedness. Utilities participate in company and local emergency preparedness programs, educating, preparing for emergency events such as natural disasters. And then you have one-call systems where they provide customers, contractors, excavators with a single phone number to call before commencing excavation or construction to ensure that pipelines and other buried facilities are not damaged. A national call before you dig or phone number, or 811, was adopted in 2008 with the support of utilities, communities, and emergency responders and government officials. Another question we'll probably ask are the end users of natural gas. For instance, the end users of natural gas will focus on commercial, industrial, electricity generation, and residential end users. So the one that I boxed over here, those what the end users are looking for. And then you have pretty much this entire workflow or this entire schematic where you have the natural gas processing plant, you have NGL fractionation, you have a local distribution and you have a natural gas that's received by the pipeline, interstate transmission pipeline, received by the local distribution company, and then it's sent to these end users. And some of the extra natural gas will go into natural gas storage. So I'll talk a little bit about each end user. For commercial, they use natural gas to heat buildings and water, to operate refrigeration equipment. Consumers in the sector also use natural gas as food in combined heat and power systems. In 20, the sector accounted for
பவித்ராவா சொல்லியிருக்கோம்.
in the natural gas 20% of the US
அவங்களால அவளை தாக்கு பிடிக்க முடியாது.
of total energy consumption. For the industrial, natural gas as a fuel for process heating in combined heat and power systems, and as a raw material, a feedstock to produce chemicals, fertilizer, and hydrogen. And in 2019, the industrial sector accounted for 33% of the total U.S. natural gas consumption, and natural gas was the source of about 33% of the U.S. industrial sector's total energy consumption. For residential end users, they would use natural gas to heat buildings and water, and to cook and to dry clothes. About half the homes in the U.S. use natural gas for these purposes. And in 2019, the residential sector accounted for about 16% of the total U.S. natural gas consumption. And natural gas was the source of about 24% of the U.S. residential sector's total energy consumption. I'll talk a little bit about transportation. So this is using natural gas as a fuel to operate compressors that move natural gas through pipelines and as a vehicle fuel in the form of compressed natural gas and liquefied natural gas. Nearly all the vehicles that use natural gas as a fuel are in government and private vehicle fleets. In 2019, the transportation sector accounted for about 3% of the total U.S. natural gas consumption. Natural gas was also a source of about 3% of the U.S. transportation sector's total energy consumption in 2019, of which 95% was for natural gas pipeline and distribution operations. I'll talk a little bit about electricity generation. It uses natural gas to generate electricity. In 2019, the electric power sector accounted for about 36% of the U.S. natural gas consumption, and natural gas was the source of about 31% of the U.S. electric power sector's primary energy consumption. Most of the energy produced by the electric power sector is coal, and it's used by other U.S. consuming sectors, and that electricity use is included in each sector's total energy consumption. Other consuming sectors also use natural gas to generate electricity, and they use nearly all of this electricity themselves. And to remember is that natural gas accounted for 38% of the total utility scale of the U.S. electricity generation by all sectors in 2020. Here are a couple charts that I wanted to show you all from the EIA, where you have the natural gas consumption by sector as of 2019, and the majority of this goes from electric power. And then you have quite a bit that comes from the industrial sector, just based on sheer scale. If you look at the growth of the natural gas consumption, you'll notice how electric power, the consumption keeps increasing year over year, with electric power and industrial being the top two sectors and users. I also wanted to show how there's natural gas consumption by end use by just the sheer numbers. Residential, commercial, so look at the last few rows. You have residential, commercial, industrial fuel, and electric power. Electric power is twice as much as residential, but it's 1.5 times more. I mean, almost 1.5 times the industrial. Another question is how natural gas commodity is set by market forces, and the buying and selling of commodity by a market player based on supply and demand determines the average price of natural gas. And there's two distinct markets. So there's spot and futures market. The spot market is the daily market where natural gas is bought and sold. And you get the price of natural gas on a specific date. If the spot market price is the most competitive, futures consist of buying and selling gas under a contract in at least 1 month and up to 36 months in advance. It's traded on NYMEX, or the New York Mercantile Exchange, and futures contracts are built are but one of the increasing number of derivative contracts used in commodities markets. Traded at different locations throughout the country. Exists across the country and the intersection of systems over the U.S. and the principle of which is known as the Henry Hub, located in
உடனே சொல்லணுமா
contracts, meaning that the price of natural gas for physical
போனஃபைட் சொல்றாரு
depending on the supply and demand for natural gas at that particular point.
நான் வரேன்
The difference between the Henry Hub price and another hub
மறந்துடுவாரு அவர்கிட்ட கேட்டுக்கோ
in the other major pricing locations, distribution companies receive pipeline, and city gates at major metropolitan centers offer another gas is priced. Here are all the hubs in the United States of major
போனஃபைட்னா காலேஜ்ல படிச்சிட்டு இருக்கான் அதுக்காக அவர் ஒரே ஒரு வார்த்தை தான் சொல்றாரு அது வார்த்தை கண்டுபிடிக்க சொல்றாரு என்னன்னு ஃபைனல்னு சொல்றாரு அவரு
a bunch.
என்ன
You'll have in West Texas.
ஸ்கூல் டிசி அங்கதான் இருக்கும் காலேஜ்ல
Henry Hub. Trying to figure out where Henry Hub is.
இருக்கும் அப்ப
Excuse me?
I request everyone to please mute yourself as ma'am is already presenting and explaining everything. So if you have anything, you can ask at the end of the presentation. So please mute yourself. Yes, ma'am, you can continue now.
Awesome, thank you. Here's the pipeline map from the EIA. You'll notice that there's a bunch of interstate and intrastate pipelines. So the interstate is between states and intrastate is within the state itself. You'll notice that there's a bunch of pipelines in Oklahoma and in Texas that are located right here. And there's a bunch of interstate pipelines located in Louisiana. So there's regular grade gasoline prices too. I just wanted to put this slide just to show you the differences in prices across the United States, where you have West Coast at $2.77, the Gulf Coast at $1.79, and so on and so forth. So this is more information on how natural gas is measured and sold. It's measured by volume and it's stated in cubic feet. A cubic foot of gas is the amount of gas needed to fill a volume of 1 cubic foot under set conditions of pressure and temperature. To measure larger amounts of natural gas, a therm is used to denote 100 cubic feet and an MCF is used to denote 1,000 cubic feet. To provide greater accuracy in comparing fuels, energy content measured in terms of British thermal units or BTUs. And a BTU is the amount of heat required to raise 1 pound of water in 1 degree Fahrenheit, or at least close to the point of maximum density. And then the energy content of natural gas differs in various locations throughout the country. For the sake of comparison, 1 average cubic foot of natural gas is about 1,000 BTUs of heat energy. So here's more information on heat energy per unit of measure for natural gas, where you have 1 cubic foot, 100 cubic feet, how many BTUs, and then this is 1,000 cubic feet where you have 1 million BTUs. Compressed natural gas, or CNG, it's sold at the retail level either by mass energy units or gasoline gallon equivalents. The National Conference of Weights and Measurements has developed a standard unit of measurement of compressed natural gas. The standard is defined as a gallon of gasoline equivalent. It means 5.66 pounds of natural gas. And this is just giving you more information of mass energy units, GGEs, mass, and in energy content. So mass can be in terms of kilograms or pounds or 1 GGE. So this is how This is how natural gas is used by consumers in the electric power generation. Wanted to show you a really simple diagram where you have electricity generation, transmission, and then distribution. So this is known as vertically integrated utility, where the power plant generates the electricity. You have a transformer that sets its voltage for transmission. Then you have transmission lines. You have a neighborhood transformer, and then you have distribution lines to houses. And then transformers on top of poles step down electricity before it enters houses. For the industrial, how natural gas is used by consumers, there's waste treatment and incineration, metals preheating, drying and dehumidification, glass melting, food processing, fueling and industrial boilers, and then natural gas may also be used as a feedstock for the manufacturing of a number of chemicals and products. So gases such as butane, ethane, and propane may be extracted from natural gas to be used as a feedstock for such products such as fertilizers and pharmaceutical products. So natural gas used as feedstock, that's the building block for methanol, which in turn has many industrial applications. Natural gas is converted to what is known as synthesis gas, and that's a mixture of hydrogen and carbon oxides formed through a process known as steam reforming. Natural gas is exposed to a catalyst that causes oxidation of the natural gas when brought into contact with the steam. This synthesis gas, once it's formed, may be used to produce methanol, which in turn is used to produce substances such as formaldehyde, acetic acid, and MTBE, or methyl tertiary butyl ether, which is used as an additive for cleaner burning gasoline. And methanol may also be used as a fuel source in fuel cells. And there's also natural gas desiccant systems. This is used for dehumidification and increasingly popular in the plastics, pharmaceutical, candy, and even recycling industries. In each of these industries, moisture-filled air can lead to the damage of the end product during its manufacture. For example, in the plastics industry, moisture can cause cracks and blemishes during the manufacture of certain types of plastics. And then adding natural gas as a desiccant system to manufacturing or drying environment, it allows for industrial users to regulate more closely the amount of moisture in the air, and it's leading to a more consistent and high-quality product. You also have natural gas absorption systems. They're being used extensively in the industry to heat and cool water in an efficient, economical, and environmentally sound way. And these industry absorption systems are very similar to those used in commercial settings. So you have, and this is just a schematic that shows you the adsorption system. You also IR heating units or infrared heating units. They provide an innovative and economic method for using natural gas to generate heat in an industrial setting. They're very useful in the metals industry, and they provide innovative ways to increase the efficiency of powder coating or in the manufacturing process. Infrared heaters use natural gas more efficiently and quickly heat materials used in the process. And natural gas is combined with a panel of ceramic fibers containing a platinum catalyst, causing a reaction with oxygen to dramatically increase temperature without even producing a flame. And natural gas in this matter has allowed the industry members to increase the speed of their manufacturing process, as well as providing a more economic alternative to electric heaters. So direct contact water heaters, it's an application that works by having the energy from the combustion of natural gas transferred directly to the flame into the water. These systems are incredibly efficient at heating water. Normal industrial water heaters operate in the 60 to 70% energy efficiency range, and the direct contact water heaters can achieve the effectiveness of 99 or almost 100%. So this leads to tremendous cost savings in industries where hot water is essential. And this just gives you just a visual of what the direct contact water heaters look like. So then I'll talk about industrial combined heat and power. They reap great benefits from operating natural gas, combined heat and power and combined cooling, heat and power systems, and it's similar to those used in commercial settings. Natural gas may be used to generate electricity needed in a particular industrial setting. The excess heat and steam produced from this process can be harnessed to fulfill other industrial applications, including space heating, water heating, and powering industrial boilers. And since the industry is such a heavy user of energy, and particularly electricity, providing increased efficiency can save a great deal of money. And the industrial sector is also subject to regulations regarding harmful emissions and the burning attributes of natural gas to help the industry reduce its emissions. We also have industrial co-firing. It's the process in which natural gas is used as a supplemental fuel in the combustion of other fuels such as coal, wood, and biomass energy. A traditional industrial wood boiler would simply burn wood to generate energy. A significant amount of energy is lost and harmful emissions are very high. And then adding natural gas to the combustion mix can have twofold effect. Natural gas emits fewer harmful substances into the air than a fuel such as wood. Since the energy needed to power the natural gas boiler remains constant, adding natural gas to the combustion mix can reduce harmful emissions. In addition, the operational performance of the boiler, including its energy efficiency, can be improved by supplementing with natural gas. Wood-fueled boilers, adding natural gas can compensate for the use of low-grade, wet wood, and allowing it to combust more quickly and completely. And this type of co-firing can also be used in the generation of electricity, whether on-site or in a centralized power plant. So this just gives you a visual of the gas burner and your feeders. So this is from the commercial side of how natural gas is used by consumers. Building heat. At supermarkets, shopping malls, hotels, museums, restaurants, and recreational facilities, natural gas powers the HVAC systems that regulate temperatures within the interior spaces. The fuel is responsible for the comfort of customers, guests, patrons, and staff at these establishments. And by regulating indoor temperatures, natural gas is also responsible for the quality of services and the preservation of foods and products at commercial places of businesses. There's also refrigeration. At restaurants, supermarkets, and other businesses that house that require temperature regulation, natural gas is one of the prime sources of power. The fuel is an ideal choice for refrigerators and refrigeration chambers because the natural gas burns more cleanly than other fuel types. Natural gas helps these places produce perishables, and cold storage foods for extended periods, thus providing an array of healthier and less costly food choices for diners and consumers. And for cooking, powering the appliances used for preparation at restaurants where stoves and ovens rely on the fuel to heat meal orders for diners and takeout customers. When you order the amount of food these places prepare daily, natural gas is responsible for significant levels of greenhouse gas reduction, as large ovens and ranges generally consume vast quantities of energy. For drying, at laundromats and other commercial establishments that wash and dry clothes, natural gas is one of the choice sources of power. With natural gas, clothing dryers can generate the necessary heat to dry clothes in a reasonable time without generating harmful side effects in the environment. And then as with ovens, clothing dryers can be a considerable source of power consumption, which makes it more practical for establishments that provide the service to choose natural gas. And then there's lighting. Natural gas is an important source of power for lighting at commercial businesses, especially for outdoor lighting. With natural gas, shopping malls and recreational facilities can light their parking lots during evening hours in the most environmentally friendly way possible. And natural gas also powers outdoor lighting fixtures along the greenery and walkways that lead to the entrances of hotels and restaurants. So for the residential sector, you have cooking, you have residential heating, and here's some facts. From the American Gas Association, 62 million homes in the US are heated using natural gas. As of 2009, the number represented 56% of households in the United States. Approximately 23% of the total natural gas consumed nationwide is used for residential purposes. This popularity is also shown through the high proportion of new homes built with natural gas heating. And then according to the US Census Bureau and its report of 2010 characteristics of new housing, 54% of new family homes completed in 2010 use natural gas for heating, followed by 43% that use electricity for heating, 1% that use oil, and 2% that use other forms. There's also residential cooling, there's also natural gas appliances, and there's also distributed generation as natural gas fuel cells. There are microturbines that both offer residential consumer and the capacity to disconnect from their local electric distributor, and they generate just enough electricity to meet their needs. Although this technology is still in its infancy, it's very promising in being able to offer independent, reliable, efficient, and environmentally friendly electricity for residential needs. Then for the transportation sector, the majority of the vehicles have switched to natural gas or government and commercial fleets. As of 2017, 3% of organizations in the transportation sector had embraced natural gas. Of that figure, 94% was a source of power for distribution across the United States. And the natural gas is a compressed natural gas and liquefied natural gas is used in cars, buses, trucks, and ships. Natural gas is also used to operate compressors to move natural gas in pipelines. Let me just show you the state breakdown of where natural gas is used. There are 5 states that account for 38% of the natural gas consumption in 2019. So you have 15% in Texas, 6.9% in California, 6% in Louisiana, 5 in Pennsylvania, and 5 in Florida. And according to, these are the percentage shares for 2019 in terms of consumption. So the majority is in Texas, where I live. Here's a video that I'm gonna stop sharing for a little bit. But here's a video that I'm going to try to share. Let's see. I guess it doesn't want to share. Well, let me show you the YouTube video real quick.
Hydrocarbons and fluids from the pure. Natural gas. Natural gas is primarily methane, or CH4, with smaller quantities of other hydrocarbons. It was formed millions of years ago when dead organisms sunk to the bottom of the ocean and were buried under deposits of sedimentary rock. Subject to intense heat and pressure, these organisms underwent a transformation in which they were converted to gas over millions of years. Natural gas is found in underground rocks called reservoirs. The rocks have tiny spaces called pores that allow them to hold water, natural gas, and sometimes oil. The natural gas is trapped underground by impermeable rock called a cap rock and stays there until it is extracted. Natural gas can be categorized as dry or wet. Dry gas is essentially gas that contains mostly methane. Wet gas, on the other hand, contains compounds such as ethane and butane, in addition to methane. These natural gas liquids, or NGLs for short, can be separated and sold individually for various uses, such as in refrigerants and to produce products like plastics. Conventional natural gas can be extracted through drilling wells. Unconventional forms of natural gas, like shale gas, tight gas, sour gas, and coal bed methane, have specific extraction techniques. Natural gas can also be found in reservoirs with oil and is sometimes extracted alongside oil. This type of natural gas is called associated gas. In the past, associated gas was commonly flared or burned as a waste product, but in most places today it is captured and used. Once extracted, natural gas is sent through small pipelines called gathering lines to processing plants, which separate the various hydrocarbons and fluids from the pure natural gas to produce what is known as pipeline-quality dry natural gas before it can be transported. Processing involves 4 main steps to remove the various impurities: oil and condensate removal, water removal, separation of natural gas liquids, sulfur and carbon dioxide removal. Gas is then transported through pipelines called feeders to distribution centers or is stored in underground reservoirs for later use. In some cases, gas is liquefied for shipping in large tankers across oceans. This type of gas is called liquefied natural gas, or LNG. Natural gas is mostly used for domestic or industrial heating and to generate electricity. It can also be compressed and used to fuel vehicles and as a feedstock for fertilizers, hydrogen fuel cells, and other chemical processes. Natural gas development, especially in the United States, has increased as a result of technological advances in horizontal drilling and hydraulic fracturing. When natural gas is burned, there are fewer greenhouse gas emissions and air pollutants when compared to other fossil fuels. In fact, when used to produce electricity, natural gas emits approximately half the carbon emissions of coal. Despite fewer emissions, natural gas is still a source of CO2. In addition, methane is a potent greenhouse gas itself, having nearly 24 times the impact of CO2. During the extraction and transportation process, natural gas can escape into the atmosphere and contribute to climate change. Natural gas leaks are also dangerous to nearby communities because it is a colorless, odorless, highly toxic, and highly explosive gas. That's natural gas.
I wanted to share them.
We now know that natural gas is mostly hydrogen. In fact, it's 4 hydrogen atoms bound to a carbon atom. This high hydrogen content and simple structure make it incredibly useful. It can be used to make products like acetic acid. Acetic acid is one of the primary ingredients in plastics. And we know that plastics are used in everything. It can also be used to make ammonia. Ammonia is one of the primary ingredients in fertilizers. Modern agriculture depends on ammonia. But the most important use of natural gas is simply to add oxygen. When you oxidize, another name for burning, you get carbon dioxide, water, and a whole lot of heat. This makes natural gas the usual heat source for most industrial equipment like boilers, burners, and kilns, and small residential equipment like water heaters and stoves, and clean enough that it can be burned directly in the house. Power plants burn it to boil water, make steam, and turn turbines. Natural gas makes about a quarter of U.S. electricity and growing. And it's growing in transportation too. It can be converted to liquid fuel, but more commonly it's compressed and burned directly in fleets of buses or taxis that have central fueling stations. Because it's a gas, transporting methane is more difficult than liquids or solids, and there are environmental impacts of producing and using it, but less than coal or oil. With an ability to contribute at large scale to all areas of energy use, heat, electricity, and transportation, and a growing global supply, natural gas will play an important role in our energy future.
And then the next lesson I'll talk about is the midstream and downstream uses. So what exactly is midstream? It's a term used to describe one of the three major stages of the oil and gas industry operations. Midstream activities include the processing, storing, and transporting and marketing of oil, natural gas, and natural gas liquids. So for field gathering, gas is sent to the processing facilities to separate water impurities or NGLs. The system is composed of flow lines, so that's a line connecting to the well pad and the field gathering station or FGS, and it's generally equipped with the fixed or mobile type of pig launcher. An FGS is a system allowing the gathering of several flow lines and permits transmission of the combined stream to the central processing facility and measures the oil-water-gas ratio. Each FGS is composed of a pig receiver, a production header where all flow lines are connected, a test header where a single flow line is routed for analysis purposes, a test system, mainly a test separator or multi-phase flow meter, and a pig trap launcher. And then you have a trunk line, which is a pipeline connecting the FGS with the central processing facility, and it's equipped with a pig receiver at the end. This is just giving you an overview of the field gathering system where you have your wells, then you have your flow lines, and then you have a bulk test manifold, you have your separators, and then that's how you separate your water, oil, and gas. This is a field gathering of what it looks like when you have a pig receiver. This is what a production header or production manifold look like. This is what a test header looks like. And then this is a test system looks like, and this is what you have in a conventional separator. And this is just showing you how the liquids or gases are separated. And this would be a three-phase separator because you have oil, water, and gas that's being separated. So field processing, you have raw natural gas that must be processed to meet the trading specifications of pipeline and gas distribution companies. And as a part of the purification of other components such as NGLs produced and pollutants extracted, it requires surface units designed and installed to measure oil, gas, and water production from the reservoir, separate oil and gas from water, remove impurities, and temporarily store gas until it's transported or moved. So this is just what the field processing looks like. And this is a basic schematic of how field processing works, where you're trying to remove your acid gases, you're removing your sulfur, and then you're removing your acid gases. You also remove your condensate and your water. You have a dehydration unit, mercury removal, nitrogen rejection, NGL recovery. Then you have a fractionation train. And then you have a sweetening unit. And this is another schematic of field processing where you have multiple processes here. So here this is more focused on propane scrubbing, propane condenser, propane economizer, you have rich glycol, you have a propane subcooler, you have a condensate scrubber, you have a reboiler. What time is it? It's about 9:55. So I'll go over this slide and then we'll open for questions. So in acid gas removal, acid gases such as carbon dioxide, hydrogen sulfide form acids when reacting with water, and they must be removed to prevent corrosive damage to equipment and pipelines. Hydrogen sulfide is also toxic and total sulfur content is normally regulated. Absorption allows acidic gases to be dissolved by a solvent, and it's to be released by regeneration in a later stage. Amine absorption is the most common process for acid gas removal. Monoethylamine, or MEA, dominates for CO2 removal, and then solutions with inorganic solvents based on ammonia are under development. I think this is a good place to stop for today, as I've gone through about 60 slides. And yeah, and I will continue the acid gas removal unit for tomorrow. I'll go ahead and stop sharing my screen, and I'm open for questions. So the question I got in the chat is, what is the major difference between conventional drilling for crude oil and drilling for natural gas in production processes also? And drilling for natural gas. So it's the same process. You're drilling, for the exploration production process, it's the same process. The only difference is you're producing two different products. And then in natural gas, you're going through more processing than you do you go through a different kind of processing than you do for petroleum. Does anyone else have any other questions?
Excuse me, ma'am. Actually, natural gas reservoir are tight gas reservoir, means tight reservoir, which have very less permeability. So, what are the major techniques that used to increase the permeability to produce the natural gas?
So it's hydraulic fracturing. That's usually, hydraulic fracturing is usually the way you could increase your permeability to access those gas reserves. Why is it often given the second priority natural gas when compared to oil in reservoir for extraction? Well, it's because oil is worth a lot more money than natural gas. Yeah, oil is worth a lot more money compared to natural gas, but depending on the area that you're in, some natural gas can contain lots of liquids, and then these NGLs could be worth a lot of money as well.
Ma'am, in the HF technique, we have to use the means many more abundant of fresh water. That is the environment concern, and many countries banned also is banning. So there is any technique by which you can replace this HF, or currently only HF is going to used?
I mean, HF hydraulic fracturing is going to be the most effective technique.
But due to environment concerned, more amount of fresh water is used in that now. So many countries, I think, are banning also, means stopping to do hydraulic fracturing.
There are a few countries that are banning, but in order to access tight permeability reservoirs, you just need to have hydraulic fracturing.
Still, no any other technique than HF?
I mean, there are other techniques you can use. I mean, you can use acid. You can even use you could even use your Like you can use acidization to get in more of your gas reserves. You can use for vertical wells. You could use gravel packs. You could use there are other techniques, but for tight plays, yeah, I would suggest hydraulic fracturing.
Hello, ma'am.
Yeah, hello.
Thanks for a wonderful lecture. Actually, I want to know why they are flaring glass in after if they are starting after they started to produce from after they start to produce oil and gas from the reservoir. Why they are flaring in the well?
Sometimes flaring happens when there isn't enough capacity to take away some of that gas. So in order to break up the gas and in order to break up the gas to where it wouldn't provide any environmental harm, you'd flare the gas.
Okay, ma'am, can you say again? I couldn't able to hear.
Can you hear me now?
Yes, ma'am, I'm hearing. I can hear you.
The way that I answer the question is sometimes when you're producing gas and you don't have much capacity to take it away, you have to flare the gas. And burning the gas is the most environmentally friendly way rather than just letting it expose to the air.
Okay, ma'am. Thank you, ma'am. I understood now.
Hello, ma'am.
Yes?
Ma'am, my question is the production of natural gas is going to increase in near future in India. So what about the latest or recent advancement for storage system which impacts good and also economical?
Awesome. That's an awesome question. I'll talk more about storage later on in the future lectures. But for storage, you would have to have enough capacity in your storage, and you'd have to have the right kind of structure for natural gas storage. I'll talk more about it in future lectures.
Ma'am, I have a question in reservoir driving mechanism. Can I ask?
Sure.
Ma'am, actually, why the reservoir pressure is declining so rapidly in oil reservoir when compared to a gas reservoir where the pressure decline is somewhat less?
Depends on your reservoir. I mean, there's some oil reservoirs out there that do not decline as much, and they're holding the pressure. I mean, and the pressure's being maintained. And there's some gas reservoirs that are declining a lot faster, and it could be a variety of issues. It could be fracture closure. It could be that you just don't have that much gas reserves. So, I mean, for the oil reservoirs that are declining rapidly, the causes of that would probably be, the causes of that would probably be like fracture closure as an example. The well has reached boundary dominated flow, for instance.
Okay, ma'am.
Any other questions? Usually, I don't think we have any more questions.
Okay. Okay, ma'am, then we will conclude this session for today and then we can have next session tomorrow.